Hi everyone, welcome to Physics 530 Physics Mathematical Methods for Educators. I am Dr. Bahar Modir, the instructor of this course. Before I start to talk about the content of the course, I would like to talk a little bit about my research background. I have graduated in summer 2017 from Kansas State University. My PhD research is coming from the field of physics education research. I am particularly interested in students' problem solving in upper division physics core courses such as quantum mechanics and electromagnetism. So I have done classroom observations. Students during the lecture pair in groups of 2 to 3 people to work on a problem. We provided them table-based whiteboards and also installed cameras. And so as they were writing, we had access to what they are talking. And so when I analyzed the data, I observed that students can use their knowledge of mathematics and physics in problem solving. But we already expected that because this was a physics classroom. But interestingly, I also observed that students can use their knowledge either algorithmically or conceptually. Being aware of different ways of a student's thinking is important because if students get stuck during problem solving, it may be not due to fundamental inability to understand the materials, but it may be simply due to not activating the appropriate part of their knowledge. And instructors, by having this awareness, can better nudge students towards more productive frames of thinking. So I use different methods and theories to investigate these manifold and context-dependent aspects of a student's problem solving. If you are interested to learn more about my research, please let me know. So this is the first time that I'm going to teach this course, which makes me super excited about it. I know that we have so many students this semester, and I would love to hear from all of you. So there is an introduction forum on the left side menu on eCollege. Please go ahead, put your name, and leave a note that what core courses you have taken so far, what other courses you have this semester, if you are a teacher, what courses you have taught before, and if you haven't taught any course before, what courses are you expecting to teach in the future. In addition to that, which is very important, please also leave a note on your available times so that we could schedule the class office hours that work for everyone. Okay, so why is it important to have a course like this? Because mathematics is a language to many sciences, including physics. When physicists observe a physical system, there are many physical quantities in that system that are in interaction with each other and have some relations. And so physicists use mathematics as a tool that enables them to model the behavior of the system. In this course, you are going to learn about different mathematical tools and then use those tools in the context of physics to be able to explain some areas of physics and some problems. So as we proceed into this course, you are going to develop a toolbox which you can use in your future core courses such as quantum mechanics and electromagnetism to explain different physical scenarios in different scales. So let's talk about the content of this course. In this course, we are going to pursue 2 main learning goals. For the details of the learning goals, please refer to the syllabus which is already uploaded on eCollege. For the first main learning goal, which is going to form half of your grade, you are going to learn advanced mathematical concepts. For the other half of your grade, you are going to learn about a student's understanding of mathematics in physics at university level. So first, let's talk about the advanced content of the course. So the lecture videos are going to be uploaded to eCollege every Wednesday of the week. I know that in this class, students have a broad range of skills. Some of you have been a physics and a mathematics major recently, but some of you have been a mathematics or physics major many years ago. And some of you that are biology students have taken some calculus courses, but may not remember all the materials. And so if you feel rusty, we are here and ready for it. And in the previous years, the students, by watching the lectures, were able to catch up to the class. In the first 2 weeks, we are going to review the calculus materials. And I would like to acknowledge the fact that Dr. Robin Locke has designed these videos, and frequently during the video she is posting some sample questions. So when you get to the sample questions, please pause the video and try to work on the solution on your own. These are important because they are like self-quizzes that can give you feedback on how you are doing in the course. And so if you have any question, comment, concern about the sample questions or the lectures overall, please let me know. The homeworks for this course are going to be assigned to you approximately on a weekly basis. In addition to that, you are required to participate in problem-solving discussion boards. Because physics is a collaborative field, I would like you to find a peer and work on the either sample problems or the homework problem in a group. Because of the online nature of the course, it makes it difficult to make these coordinations, so there is another forum on the left side menu. Please go ahead and put your name and your available times. For example, if you are available on Saturday and another student is also available on Saturday, then you can pair in a group and work on the problems. When you are writing the solution, please make sure that you have the appropriate citations. Participation in the problem-solving discussion boards are going to be very useful, as it will give you another opportunity to practice the content of the course, share your ideas, and give feedback to each other. So, the other half of your grade is coming from learning about the students' understanding of mathematics and physics at university level. Research shows that students, despite having a background mathematical knowledge and having mathematical tools, they may not be able to use that in the context of physics problem solving. So we are going to read peer-reviewed, research-based methods papers, and you can download these papers from the Journal of Physical Review Special Topics, Physics Education Research. By reading these papers, we are able to answer to questions such as how students blend information from mathematics and physics, how students do procedures in problem solving, and how they use particular mathematical tools such as integration, or how students frame a problem solving situation. By frame, I mean how students know what's going on here and decide what subset of their knowledge to activate. After reading each paper, you are required to write a reflection based on the assigned prompts. There will be a rubric available to you that explains how you will be graded on your reflections. After writing and submitting your reflections, there will be another document available to you which I will explain about the research side of that paper. I will explain about what theory they have used, what research questions they have, and what methodologies they have discussed in their papers. After reading this document, you are ready to post your comments on the reading discussion board. You are required to leave 3 comments, and 2 out of 3 have to address other students' comments. This will help to have a productive and ongoing discussion. There will be rubrics available to you to explain how you will be graded on both the problem-solving discussion board and the reading discussion board. I believe that you will find participation in the reading discussions fascinating and interesting, because the topic of the papers are tried to be related to the content of the course. So you already have some thought on the content, you have already read the research side of the papers, and all of you have experience with learning physics and mathematics, and some of you have a lot of teaching experience at high school level. And so I'm also going to participate in the reading discussions, and I'm looking forward to talk to you and hear about your ideas. So by participation in these reading discussions, you are going to be able to generate some new ideas, some new research questions, some suggestions on how to apply the results of the paper to the high school level, and also you can make a comment on what you found interesting or even confusing about the paper. I certainly encourage you to go through the syllabus, because I didn't cover the details of the syllabus. Please refer to the schedules and the deadlines for homework assignments, for readings and discussion boards, the midterm and final exams, and also please go through the course and the university policy. At any time during the semester, if you want to talk to me about your progress, email me and we can meet in the class office hours or even schedule a video chat to talk in detail about anything related to the course. That's it.